All right, so for our test review, Unit 2. So our first section is going to be multiple choice, and the multiple choice will come from the notes, and I'll refer to that again at the end when we deal with the last few questions. So classify the following as a heterogeneous mixture, a solution, a compound, or an element. Remember, I am not going to ask you any that we have not done in class. We've done all of these already in class, and the reason is because everyone has a different science background. So it's really not fair to ask a question that someone in the class understands because they read science in the newspaper, they pay attention to science on different channels like the Nature Channel, the Science Channel, and others don't. And so to even the playing field, again, like I said, we're only doing ones we've done in class. So silicon would be an element. It is on the periodic table. That is the most specific. Sugar would be a compound. We may not know the chemical formula, but we know sugar has one. And since it has a chemical formula, elements bonded together to make a formula, it is a compound. Soil would be a heterogeneous mixture. That's the catch-all. If it's not an element on the periodic table, if it's not a compound, chemically bonded elements, and it's not a solution, which would mean a mixture that is uniform, something that is perfectly dissolved in something else, has the same composition throughout, then everything else is a heterogeneous mixture. So nitrogen would be an element. Air is a solution. It is uniform. It has the same percentages. Sand, a heterogeneous mixture. Although it does contain SiO2, it contains other substances which causes it to be a mixture, or a heterogeneous mixture. A car would definitely be heterogeneous. Pepsi is a solution. It's the same throughout. A banana, heterogeneous mixture. Element, a solution, Kool-Aid, and salt water. Both of those are perfectly dissolved. All right, moving on to the next section. Which of the following are chemical? I'll just label them as chemical or physical. And in order for it to be a chemical, like burning wood, you have to produce new substances. Again, different science backgrounds, and we're going to do ones that we've talked about in class. We've done a lot of these, though. Dissolving is a physical change. You're just breaking it down into smaller pieces. Boiling, all phase changes are physical changes. Still the same stuff, it's just changed form. Tearing paper, cutting wood, just physical changes. That's a chemical change. You're making a new substance. That's the definition of a chemical change. Rusting, you're making a new substance. Anything burning, exploding. But kicking a football would be physical. Melting, physical change. Evaporating, physical change, phase changes. Spoiling would be a chemical change. Producing new substances. And toasting, again, a chemical change. Which of the following are physical properties? Density is a physical. Reactivity, though, is a chemical. These are the two most missed ones, odor and color. They are physical properties. Although they normally indicate a chemical change, they are themselves physical. Solubility is the ability to dissolve something. Again, physical change. Ductility and malleability, two definitions we've learned. Ductility, the ability to be drawn into a wire. Metals are ductile. They can be stretched into a wire. And malleability, the ability to be shaped with a hammer. Again, a metal trait, and it is a physical property. Length and mass, both physical. Chemical, and physical, a phase change, its freezing point. Rust resistance, rusting would be chemical, so the property of resisting rust would be a chemical property. And then burning, again, chemical. All right, so now for the naming section, we're going to have to be able to identify the acids, the ionic substances, and the molecular compounds all in a mixture. So we have to pay attention now. For example, the first one is two nonmetals. So this would be dinitrogen trichloride. Dinitrogen trichloride. Tri, I know my handwriting's terrible because there's three chlorines, two nitrogens. So remember, it's not the charge because they're molecules, meaning they're covalently bonded, meaning they're atoms, not ions. So they don't have a charge. So we say there are two nitrogens, so it's di. There are three chlorines, so it's tri. And remember, we also learned that if the first one is only one, the mono is left off. I told you the one to remember that rule is carbon dioxide, because we know that one, and it would be monocarbon dioxide, but we leave the mono off. All right, the next one would be iron, Roman numeral 2, phosphate. You could also name this ferrous. Remember the lower charge. Magnesium, hydroxide. Ammonium, sulfate, copper. No, copper needs a Roman numeral. It would be a 1. in this case because there's nothing down here on the polyatomic ion, and that would be phosphite. And we could also name the lower charge of copper, remember, cuprous. Let me move this up. Lithium carbonate. Next row, or next column, we have copper again. This time it's copper, Roman numeral 2, and it would be iodide, and this would be cupric iodide. A little tricky here, oxygen is a -2, so then tin must be a +4, and it would have been SN2O4, which gets reduced. So this is tin 4 oxide, which we could call, remember, stannic, the higher charge of tin. Potassium permanganate, polyatomic ion. Now we have an acid. We learned to name the acids. This has oxygen in it, and so this is the nitrate polyatomic ion, which makes it no prefix, nitric acid. Silver hydroxide. Aluminum hydroxide. Manganese needs a Roman numeral. Manganese 2 carbonate. Manganese 2 carbonate, because that's a -2. So -2 for carbonate, so that has to be a +2. Aluminum phosphide binary. Lithium perchlorate, polyatomic ion, ClO4. Copper, Roman numeral 1, hydroxide, and that once again could be cuprous hydroxide. One or the other, you don't have to give both. Another acid starts with hydrogen. This is a binary acid, and we learned binary acids get the prefix hydro and the suffix ic. So that would be hydroiodic acid. And then the last one, again, 2 nonmetals, so diphosphorus. Remember, you don't change the ending of the first element, it's phosphorus. And then heptaoxide. We learned when there's an O and an A there, or we would drop, or an O and an O, we would drop the A off of the prefix and say heptoxide. And the one I told you to remember that is CO, carbon monoxide. It's really monocarbon monoxide, but we leave the mono off the carbon, the first one, and then monoxide, we drop the O, and it is monoxide. All right, next page, other side. Oops. All right, now we're writing formulas. So plumbus, that's lead, and the OUS tells us the lower charge, which is lead +2. Nitrate is NO3 -1, so PB NO3 parentheses 2. We cross the 2. Potassium is K +1. Sulfide tells us it's binary, and so K2S. Di and oct, these are not charges, remember, but how many. So we don't cross when we have prefixes. It tells us how many we have, not the charge. They're atoms inside of a covalently bonded molecule. Hydroiodic tells us it's binary. I probably shouldn't have picked the same one. I told you to fix this one in class today because we did not name the other acids. We only did binary and the polyatomic ions that end in -8. So sulfuric would be sulfate. So we have hydrogen with a +1. We have sulfate with a -2. And so the correct formula for sulfuric acid is H2SO4. Sodium, Na +1. Carbonate -2. Cupric, the higher charge, which is +2. Nitrite, NO2. Zinc chloride, +2 -1. Li +1 -1. +1 -1. All right, prefixes again. Notice the mono is left off, so it's just Si and O2. Cobalt 2 oxalate, +2 -2. Auric, the higher charge of gold, which is +3. And please do not forget the parentheses on the hydroxide again. Remember, it is a polyatomic ion. If you have more than one of the polyatomic ion, you must have parentheses. I know we remember to do it on nitrate because of the 3. Remember to do it on nitrite because of the 2. But hydroxide, though it does not have a subscript on the H, is a polyatomic ion. All right, chloric acid, no prefix, so that means we're looking for the polyatomic ion that ends in H, which would be chlorate. So H plus 1, chlorate, ClO3, and minus 1. So the correct formula, HClO3. Fix the formulas. What this means, now notice I changed it a little bit, if needed. So now you have to use your higher order thinking skills. You've got to demonstrate you know what you're talking about. By looking at this, I know it's wrong because lithium is a plus 1 and sulfate is a minus 2. So the correct formula for that one is Li2SO4. I know this one's wrong, plus 2 minus 1. So MgI2. Copper can be a 1 or a 2, but that's a minus 3. So I can pick there. I could either use, let's say I'm going to pick copper with a plus 1. So I'd have Cu3PO4. If I picked it with a 2, I'd have Cu3PO4 2. You don't have to do both. You can just pick one. Plus 1, minus 1. This one's good. Minus 2, and iron can be a plus 2, so that one's good.
Excuse me, I have two announcements for seniors. Please be
Plus
advised
2,
first that King's
minus
College,
1,
DeSales University,
plus 1, minus 2,
and the University of Scranton will all be visiting next week.
plus 1, minus 1.
We return from our brief vacation Tuesday, Wednesday, Thursday.
Plus 1, minus 3.
Sorrow to sign up. Again, King's College, DeSales University of Allentown.
Minus 3, this can only be a 2 or a 4, so again, two choices.
Seniors who are participating in the yearbook candy sale.
Or
next Thursday is the deadline. I believe it's $144 American dollars that you owe.
This is just reading your notes. Make sure you know what a solute is. That it's dissolved. The solvent is the one that does the dissolving, and it makes a solution, which is also known as a homogeneous mixture. Know the following: a compound, an element, an ion, malleability, and ductility. I am going to ask multiple choice questions about those. And these two questions are going to be on there word for word. Be able to explain why a solution is always a mixture, but not every mixture is a solution. And the reason for that is every solution is a homogeneous mixture. But not all mixtures are homogeneous because some mixtures can be heterogeneous. So that's a good answer for that. Again, solutions are homogeneous, so they're always a mixture. They're a homogeneous mixture, but not every mixture is a solution because some mixtures are heterogeneous. Be able to explain the difference between molecular and ionic. This is a positive and negative ion, identified normally by a metal, and either a non-metal or a polyatomic ion, whereas this is two or more non-metals. So good luck, and if you have any questions, send me an email.